everyone, welcome to this new video lecture series in which I'll be taking GATE and CSIR UGC NET mathematics questions which have appeared in these exams in last 5 years. And to begin, I have selected the topic linear programming problem. This is a topic which comes in both the exams, in GATE as well as UGC NET paper. So I'll be taking up one question each day so that you can learn the concepts better and quickly. So without a delay, let's take the question of the day. So this question was asked in GATE 2019 exam. You read the statement first. For a balanced transportation problem with 3 sources and 3 destinations, where costs, availabilities and demands are all finite and positive, which one of the following statements is false? So we have to look at all of these statements one by one and figure out the false statement. So to attempt this question, the prerequisite is you should have a thorough knowledge of transportation problem, and in particularly the concept of balanced transportation problem. So let me recall you very briefly what is the transportation problem in general looks like. So in a transportation problem, the data given is in the form of a matrix. So this side you have m sources and in the columns you have n destinations. So the shipping is taking place from the sources towards the destination, and for each shipping combination of source and destination, we are given the cost of shipping, and then we are also given the availabilities at each source and the demands. So these are always the data given to us. So let's begin with the first part and try to answer this. So let me first give you the notation. Number of sources is 3, so m is 3. The number of destinations is 3, so n is also 3. So the first part is telling you the transportation problem does not have unbounded solution. Does not have unbounded solution means it has a bounded solution, because a transportation problem is also a linear programming problem. So that means LPP is bounded, it's never going to have an unbounded solution. So for that to understand, let's have a look at its objective function, because the boundedness and unboundedness of a linear programming problem is decided from the objective function. So this is the LPP formulation. I am not going to write the complete formulation, but just the objective function here. So I is number of sources 1, 2, 3 and j is also 1, 2, 3. Since it is given that costs are positive and xij's, these are the number of units to be transported from one particular source to destination. So this quantity is always positive. This is also positive, non-negative I should say. So obviously this z is always going to be non-negative. So the minimum of all non-negative numbers, this number is definitely greater than equals to 0. So that means this cannot grow towards negative infinity. It definitely is having a lower bound which is 0. So that means its objective function is always bounded. So that means this part is true. So let's look at B part. The number of non-basic variables of transportation problem is 4. And so for this we need to know the formula that the number of basic variables of a balanced transportation problem is m plus n minus 1, where m is 3, n is also 3. This is given to us in the question. So this is 5, but they are asking about the number of non-basic variables. So for that we need to know the total number of variables. The total number of variables is m into n, which is 3 into 3, which is 9. So obviously the number of non-basic variables turns out to be 9 minus 5, which is 4, because this is the total, this is a basic, so the non-basic is the difference of the two, so which is 4. So that means this part is also true. Let's look at C part. Dual variables of transportation problem are unrestricted in sign. This is default true because this is one of the standard results. So obviously if you are attempting the exam of GATE or UGC CSIR, so you should be clear with the standard theoretical results. So this comes from the theoretical result that whenever you write the dual of a transportation problem, the dual variables are always unrestricted in sign. So this is also true. So no need to even look at the D part, no need to even do the calculations for D part, because we had to choose the false statement. So if we are very sure that A, B, C are true, then D is definitely false. If you want to convince yourselves, you can figure out, you can find the number of basic feasible solutions. So for that I can tell you the formula how to compute the maximum number of basic feasible solutions of a transportation problem. This is Mn C m plus n minus 1. So this is 9 C 5, and so they are saying it has at most 5 basic solutions. However, if you compute it, this will be 9 factorial divided by 5 factorial into 4 factorial, which is obviously, without even calculating, we can see that this number is strictly greater than 5. So this part is false. So that's about question 1. We'll meet in the next video with another question. Thank you.